So we are going to go ahead and practice balancing reactions. So when we balance a reaction, you are going to see it in a few ways. It might say balance this reaction. It might say here is the following unbalanced reaction. Your job is to make sure that all of your elements on the left-hand side or the reactant side are equal to the number on the right-hand side. Okay, so we're going to try this out and see how this feels. Okay, so let's go ahead and label. I like to label left and right, especially when we're on screen, because it's easier for us to kind of identify which side we're talking about. But I also want to remind you that the left-hand side is called the reactant side, and the right-hand side is called the product side. Okay? And so the other thing I like to do is at the arrow, I like to put a squiggle that really helps me visualize that I have stuff I'm starting with and I have stuff I'm ending with, and those need to be equal to each other. Okay, so those are the few things I like to start with to make it a little bit more straightforward for myself. Now, I've given you your first few problems scaffolded where there are lines where your coefficients are going to go. In the future and going forward, you're not going to see those. So you may want to add these marks for yourself when you come across unbalanced reactions. Okay? So let's go ahead and get started. So on the left-hand side, or the reactant side, I'm looking at hydrogen. I've written hydrogen here. There are 2 hydrogen because there's this 2 subscript. Over here, we have oxygen, right? It is separate because there's a big plus sign in between. And this oxygen, there's actually also 2. Now, let's take a look at the right-hand side. There's 1 molecule, and it has hydrogens and oxygens. This hydrogen has 2, so I'm going to put a 2 here. And there is no subscript here, right? So if it's a missing subscript, it's always a 1. Now, as you look at this, notice that your hydrogens actually match. There are 2 and 2. You're good to go. But your oxygens actually don't match, right? There's 2 on one side and 1 on the other, which means that we need to make them match. Okay, so let's go ahead and make that happen. So because there are 2 oxygen on the left and 1 on the right, I can only use multiplication. So I can multiply this right oxygen by something to make it equal to this number. So there's 1 here, there's 2 there, so I'm going to multiply by 2. But I have to document that I did this. I can't just randomly do weird multiplication. So if I multiply this oxygen, it's right here. It's attached to this molecule, so I'm actually going to put the 2 in front. But that means that that 2 is touching everybody. So it has to multiply by the hydrogen and by the oxygen. I already took care of the oxygen, right? We did times 2. So let's go ahead and also add it for the hydrogen. So 1 times 2 is 2. 2 times 2 is 4. All right, now, if you remember, we had just said that this oxygen and this hydrogen mostly were good to go. But now let's take a look again, right? Your oxygens, now they're matching, right? 2 and 2. But look at your hydrogens. Your hydrogens are no longer matching, right? There's a 2 and a 4. So we need to fix those. So what we're going to do is the same process that we just did. There are 2 hydrogen here. There are 4 here. So I'm going to take this 2 and I'm going to multiply it by 2 because that makes it 4. So 2 times 2. And remember, if I put something down here, I need to document it. So I'm going to document it. And I'm going to multiply by this hydrogen. And notice there's a big plus sign in the way, which means it's only going to multiply by my hydrogen. There's a big break here, so it doesn't touch this oxygen. So now I have 4 hydrogen on the left. I have, there we go, 4 hydrogen on the right. I have 2 oxygen on the left. I have 2 oxygen on the right. So that means that my reaction is now fully balanced. So I'm actually done. If you are somebody who really wants everything filled in because it makes it feel like you have completed it, go ahead and you can add a 1 here just as a placeholder if it makes it a little bit easier for yourself, okay? But this reaction is fully done. Nice job. All right, we're gonna keep moving. Let's go ahead and take a look at the second one. We're gonna do the same thing, okay? We have our spots for our coefficients. We're gonna list out our elements on both sides, and I like to list left and right, and then break up my reaction in half. Okay, so on the left-hand side, right, if I'm looking at Li, there's an invisible subscript, which means I have 1. But Br actually has a subscript, it has 2. So we're gonna put a 2. On the right, I have lots of invisible subscripts. So Li has 1, and then Br also has 1. That's it, okay? Now if you take a look at it, they're not matching. The Li's are matching, but the BRs are not. So we need to actually fix that. So there's 1 BR here and 2 here. So I'm going to take this one and multiply it by 2 to make it equal to 2. Remember though, if I do something below, I need to document it. So I'm going to put a 2 up here. And since it's touching the whole molecule, we're going to multiply it by everybody inside. Right? So we did the BR. There's the times 2 for the Li. And so now we get 1 times 2 is 2. 1 times 2 is 2. We fixed our BR, right? They're both 2's, but our Li's don't match anymore. Now there's 1 on the left and 2 on the right. So we are going to fix that now, right? So there's 1 on the left. To get it to 2, I'm going to multiply it by 2. And because I multiplied it down here, I need to document it. Okay, and so there's a big plus sign in between, so that means this 2 only is multiplying the Li. So 1 times 2 is 2. And if we look, you have 2 Li on the left, 2 Li on the right. That one's good. You had 2 Br on the left, 2 Br on the right. That's good. And you are done. You can write balance for yourself if you like that. Oops. And if you are somebody who really needs to make sure you fill in every spot for yourself, you are welcome to add a 1 right here. Okay, and that means you are done with it. We are going to do 1 more. Now, I warn you, I accidentally made a typo on this one, so we're going to fix that typo first. Can you go ahead and make this H3 into an H2? I'm so sorry. I made a typo. Everything else is correct, okay? Please don't change any other number, just this H2 on the left, okay? Okay, let's go ahead and do our left and our right. We'll make a squiggle to break it up, and then we will get started. So on the left, we have 2 nitrogen. We have 2 hydrogen, right? Because we fixed my typo. On the right, nitrogen doesn't have a subscript, so it has an invisible 1. And hydrogen has 3. Okay, so notice that nobody is matching this time, right? That means we don't have a clear way of who's going first. That means you get to choose whoever you want, okay? I'm going to start from left to right, but again, you can start wherever you want. I see 2 nitrogen and 1 nitrogen, so I'm going to multiply my 1 by 2. And because I did it down here, I need to document that 2. And I'm going to have to do it to everybody in my molecule, right? I got to multiply it by 2. So I did my nitrogen, and now I'm going to do the hydrogen. All right, so let's go back and solve. 1 times 2 is 2. 3 times 2 is 6. All right, so we fixed our nitrogen, right? There are 2 and 2. Excellent. But your hydrogen got real weird. Your hydrogen got all sorts of wonky because now you have 2 and 6. So let's go ahead and look at this hydrogen. I have 2 here and 6 on the right. So I'm going to multiply my 2 times 3 to make it equal 6. So 2 times 3. And then don't forget, we need to document that 3. There it is. And because H2 is by itself, right, there's a big arrow in the way, it just touches the H2. So that means I have 6. So now let's take a look. I have 6 and 6 hydrogen. I have 2 and 2 nitrogen. So we are done. Oops. And again, if you need to mark off that you completed it and it helps you, go ahead and put in a 1. And that is all you need to do to balance as you are working your way through these.